Welcome. In this lecture, I'd like to continue a little bit with going through kind of the language of proofs. So another logic word is or. So again, this is one of these things where this is kind of equal opportunity to everybody, no matter whether English is your first language or second or third, or how comfortable you are with it, because this is a logic word. And so learning to use this is really learning to make logical statements in words. Okay, so here we go. So here's the one that we want to look at in this lecture. So we want to do this is kind of just logic symbolism. So this is like P or Q. Okay, so a statement like this has the meaning. So this is, I would write this as, so this means P, or, and a lot of times you'll see me capitalize that just to emphasize that I'm using a logic word, or Q. Okay, so that's kind of the meaning out in words, or how you would write it in words. And this has a name, so this is called the disjunction. Okay, and so one of the ways, so something that I haven't done yet in my lectures is truth table. So this is best described by a truth table. So let me show you. Okay, so we have P, and then we have Q, and then we have P or Q. Okay, so what's going on here? Let's make our table. And we're going to divide this. There are kind of 4 circumstances, because for each of P or Q, they can be true or false. Okay, so we're looking at, so we have the circumstances where P is true or false. We have the circumstances where Q is true or false. So now we have all the combinations of true and false there. And what we're going to get for our or statement, write that in red. So if they're both true, then P or Q is true. If one is true but the other is false, for both of these circumstances, again, we have true. If both are false, then we have false. Okay, so what do each of these kinds of lines mean? So the first line really means if P and Q are both true, then their disjunction, so P or Q, is true. That's kind of what that line is saying. And then this line is telling me that if P is true and Q is false, so if P is true and Q is false, then their disjunction, or the or statement, is going to be true. Okay, this one is kind of similar, so let's you can kind of parse it. It's if Q is true and P is false, then their disjunction is also true. And then the last one is if P and Q are both false, then their disjunction is false. Okay, so to summarize, what do we have going on here? We have that taking P or Q, so P or Q is true precisely if at least one of P or Q is true. So, to show a statement like this, so to show a statement P or Q is true, what do you need to do? You either need to show that P is true or show that Q is true. So to show that this is true, either show P is true. So either show P is true, or, look at that. I put that, suggestively. Or show that Q is true. So, or show Q is true. Right, but this is an inclusive or, so you only need to necessarily do one of them. Or, but it's also, right, so this is not the place to say this is an inclusive or. In general, this is an inclusive or for those who like logic, meaning that it's possible that both are true. Okay. So the other one is to show, to show a statement like this, so this disjunction is false. Right? You actually show that P is false and show that Q is false. Okay, so then you need to show P is false, and this one I won't do with the, okay, that Q is false. Right? Okay. And actually, and maybe I'll emphasize this here, that this here is actually, so this, okay, so where does this come from? So it comes from one of De Morgan's laws, so De Morgan's laws. Right. And so the De Morgan law that it comes from is that taking, if I want to take P or Q, and I want to negate it, right? This is the negation, so this is not, or the negation. So how do I negate something like that? I'm going to do that by, and then you're going to see this, I'm going to have to use notation here that you're going to have to see in the next lecture. But it's going to be that I'm going to take the negation of P. So I'm going to take P negated, and then I'm going to switch this over to the and symbol. So this just means and, but you'll see this in the next lecture. And then we have the Q statement, negated. Okay, so we need to actually, so this negation is that one and also that one over there. Okay, so whenever I put a bar over something, I mean I'm negating it. In this context, later it'll mean something else, but when we're doing logic statements, this is how we do it. Okay, so what is the disjunction? So P or Q. What does it mean? So a statement, P or Q, is true precisely when one or more of P or Q is true. So as long as one of them is true, we're great. They can both be true. That's this statement here, which is why it was called an inclusive or. And the only way for it to be false is if both are false. So if you want to show that a statement like this is true, you just need to show that one of these is true. To show that it's false, you actually have to show that P is false and Q is false, which is actually kind of one of De Morgan's laws, which is that if you want to negate the statement P or Q, then you need to take negation of P and negation of Q. And we'll talk about the and symbol a bit more in the next lecture. So I hope this was helpful and made some sense, and I will see you in the next lecture.